Hello, bachcho. So let's read out the question first. A piece of metal floats on mercury. The coefficient of volume expansion of metal and mercury are gamma 1 and gamma 2 respectively. If the temperatures of both mercury and the metal are increased by amount of delta T, the fraction of the volume of the metal submerged in mercury changes by the factor of, while given in bracket, ratio of final fraction to initial fraction is according to question we have to find here. So first of all, let's say the key concept for the question that we are going to use here is the law of buoyancy. So according to law of buoyancy, what we know that when we are having any object and it is immersed into the liquid, so just because of weight to equivalent that a buoyant force is exerted into the upward direction by the liquid. Okay, now to clearly get understand the question, हम क्या सपोज कर लेते हैं कि मेरे पास एक कंटेनर है जिसमें मरकरी को फिल किया गया है। ये हमारे पास एक मेटल का पीस है, ओके, जिसका मास कुछ m के इक्वल है। सो जस्ट बिकॉज ऑफ वेट ऑफ मेटल पीस, the weight exerts in downward direction, okay, and it is generally given by m into g, where g is the acceleration due to gravity. Now to equivalent this, the force will exert in upward direction by the fluid, which is given by F is equals to the volume displaces of the fluid into density of fluid multiplied by the acceleration due to gravity, that is g. Now let's suppose volume of the fluid is capital V and volume for the metal piece is small v here. Similarly, density of the fluid is rho hd because it's in mercury, and density for the metal is rho of m. So by using this concept, as this band force is equivalent to weight of metal piece which is acting in downward direction, so we can equate both of them. So it can be written as volume displaces multiplied by the density of fluid, that is rho hg, multiplied by g. This should be equals to m into g. Now here this gg can be cancelled out. While it is known to us, mass is given by the volume into density, but here volume will be for metal piece and density will also be for metal piece, right? Now we can substitute this here. We get v into rho hg will be equals to small v into rho m. Now if we try to form the ratio here, so we can write a small v by capital V. This should be equals to rho m by rho ht. Let's say this as k1, okay, and also let's suppose this as equation number 1. अब क्वेश्चन में बोला कि जा रहा है if temperature of both mercury and metal are increased by an amount of delta T. When delta T is increased, okay, means when temperature is increased by delta T, in that case the new fraction we will form as V dash by capital V dash is equals to rho dash of m by rho dash of ht. इसको हम मान लेते हैं रेशियो as k2. Let's say this as k2 and let's say this as equation number 2. Now what we will do, we will simply divide the equation 2 by 1. So what we get here, that is k2 by k1 will comes out equals to rho dash of m बाय, सो K1 की टर्म को मैं यहाँ पर लिख दे रहा हूँ, दैट इज रो ऑफ M मल्टीप्लाई बाय रो ऑफ HG, न्यूमरेटर में चल जाएगा और डिनोमिनेटर में यहाँ पास कहा जाएगा रो डैश ऑफ HG। ठीक है, अब मैं रो ऑफ HG को रो डैश ऑफ HG के फॉर्म में लिखूं, दैट इज बाय यूजिंग द expansion coefficient. So what I can write down this as, I can write rho dash of M by रो ऑफ M मल्टीप्लाई बाय रो एच जी को मैं इस तरीके से लिख सकता हूँ, रो डैश ऑफ एच जी इन ब्रैकेट 1 प्लस gamma 2 into delta t डिवाइडेड बाय, सॉरी, डू वन करेक्शन हियर, यहाँ पर हम ये रो डैश ऑफ एच डी को एज इट इज रखेंगे। अब मैं रो ऑफ एम को क्या लिख सकता हूँ, रो डैश ऑफ एम इन ब्रैकेट 1 प्लस gamma 1 into delta t। तो देखिए यहाँ से ये all the four terms will get cancel out and simply we will get the ratio of K2 by K1 as 1 plus gamma 2 delta t by 1 plus gamma 1 into delta t। And see, gamma 2 और gamma 1 क्या है, वॉल्यूम एक्सपांशन ऑफ मेटल एंड मरकरी है, और यही तो हमसे पूछा गया था टू फाइंड the ratio of final fraction to initial fraction, and we have found this here by using the concept of law of buoyancy. Now according to this, let us check the option. So option A will become correct answer for this question. So this is the required solution. I hope it is clear to you. Thank you.